Hello, this video is going to be on how you simplify square roots. I'm going to start with this problem simplifying the square root of 75. At this point, you know there are some square roots like square root of 25, square root of 100, where they have like a nice whole number answer. Square root of 25 is 5, square root of 100 is 10. There is no square root of 75. Now, if you were to type that into your calculator, you're going to get a decimal. The decimal is just going to go on forever and ever. There are times where we don't want a decimal. Instead, we just want to simplify the square root. Simplifying square roots are going to mean our answer is going to end up having smaller numbers in it. It's going to have a smaller number outside the square root and a smaller number inside the square root. It's kind of like finding what you can square root inside the square root. There are two ways you can do this, and the first way is using something we call a factor tree. A factor tree is different than listing all the factors of numbers. What a factor tree does is you take the number inside the square root, so in this case 75, and you pick any two numbers, you pick a pair of numbers that multiplies to give you 75, just not 1 and 75. So there can be a couple options. The first one that comes to mind for me is 3 and 25. Now, it doesn't matter how you start your factor tree, because the focus isn't on how you start, it's what you get at the very end of it. You're using your factor tree to break this number down into prime numbers. A prime number is a number like 3, where the only pair of numbers you can multiply to get 3 are going to be 1 and 3. So 3 is prime, because there's nothing besides 1 and 3 that multiply together to give you 3. 25 is not prime. We can keep going with 25. So what the factor tree does is we're going to keep going with 25. We're going to break it into another pair of numbers that multiply to 25. There is only one pair of numbers. Hopefully you're thinking 5 and 5. So our factor tree is going to keep going until everything we have is prime. So we already said 3 is prime. I've got 5. 5 is also prime because the only pair of numbers you can multiply to get 5 are 1 and 5. So all we're left with here is prime numbers. Fun fact about the prime numbers, if you were to multiply these all back together, it's going to give you what you started with. So if I do 3 times 5, that's 15. 15 times 5 gives you 75. So in order to simplify our square root, we need to know these. We need to know all those prime numbers. How simplifying square roots works is if you have a pair of prime numbers, the pairs go outside the square root. And if you have any number that doesn't have a pair, it would go inside your square root. So for example, I have a pair of 5s. So I'm going to write 1, 5 because I have one pair of 5s. I'm going to put a 5 outside the square root. And then this 3 right here, this 3 does not have a pair. So the numbers without pairs go inside. What this means is the square root of 75 is the same thing as 5 times the square root of 3. If you wanted to check that into with a calculator, you could type in square root of 75, you would get a decimal. Then if you type in square root of 3 and then multiply it by 5, those should equal the same decimal. It's kind of like a different way to see that these two are equal to each other. So that is one example, is with a factor tree. I have another example for us to look at. Next, we're going to look at square root of 48. I'm going to do this one the same way. I'm going to do it with a factor tree, but then after we've done the factor tree, I'm going to show you the second way you can do these. If you wanted to pause the video now, see if you can just make yourself a factor tree. It might look different than the one I end up doing, but at the end of the day, the prime number should be the same. So if you want to try a factor tree now would be the time to pause. All right, maybe you have a factor tree. I'm going to start with 48. And then what we need is any pair of factors of 48 besides 1 and 48. Like I said, there's a lot of different ways you could start off your factor tree. I'm thinking I'm going to do 4 and 12. 4 times 12 gives you 48. Remember, the goal is to keep going until everything you have left is a prime number. So looking at 4 here, 4 is not a prime. 4 we could split into 2 times 2, because 2 times 2 is 4. If I look at 12, 12 is also not prime. There's a couple different things you could do with 12. I'm going to do 6 and 2. If I look at what I've got now, I've got a lot of 2's. 2 is prime. 6 is not, though. 6 I could keep going, and I could say 6 is the same thing as 2 times 3. Looking at what I have left here, I've got 2, 2, 2, 3, and 2. So like I said, I asked you to try a factor tree at home to pause the video. You might have started off differently, but you should have all the same prime numbers as I do. The next step is going to be what we're doing with all these prime numbers. So if you recall from the first example, when we simplify, there's going to be a number outside your square root, and then there's going to be a number inside your square root when we finish simplifying. What we're looking for are pairs. So looking through all of these numbers here, I see I have a pair of 2's. One pair of 2's means 1, 2 goes outside. I also see I have another pair of 2's. Sometimes students think that the numbers need to be next to each other. They don't. I've got a pair of 2's here. I've got a pair of 2 here. Because I have another pair of 2's, I'm going to put a second 2 outside. I don't want it to say 22, though. It's going to be 2 times 2. All of this that we've been doing is multiplication. So if you have numbers next to each other, we're going to separate them with a multiplication sign. The last part is what goes inside. Inside, we have our 1, 3 all by itself. So my 3 will go inside. Now for this one, we have an extra step. Instead of saying 2 times 2 outside, we can go ahead and multiply that. So we're going to say 2 times 2. Well, that's the same thing as 4. So our final answer is 4 square root of 3. We're saying the square root of 48 is the same thing as 4 times the square root of 3. Now I said that at the beginning of this video that there are 2 different ways you can simplify square roots. One way is by doing this with a factor tree. I've taught this many times, and I have found that a lot of students like having a factor tree, right? You've got like a series of steps you can do to simplifying your square root. It doesn't matter how you start, right? It's just what you end up getting at the end. So there's a couple different ways to do it. You have options. There is another way, though, to do this. And the other way relies on knowing your multiplication facts pretty well. But if you do know them really well, it's a lot quicker to do. So I like showing it both ways just because depending on the problem, depending on the student, different ways work for different students. The other method involves is finding a number you can square root inside 48. So when we talk about numbers you can square root, that goes back to what we had said at the beginning. Numbers like the square root of 4, square root of 9, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, and they go on forever. So when I say finding a number you can square root inside 48, thinking about all of these numbers and finding the biggest number on this list that is inside 48. What I mean by that is thinking about a multiplication problem where the answer equals 48 using the largest number possible on this list. It can get tricky because sometimes there's more than one number on this list you could use, right? I started off my factor tree earlier with 48 by saying 4 times 12. The largest number you can use, though, on this list would be 16. How it works is we say the square root of 48. Well, 48 is the same thing as 16 times 3. Like I said earlier, it involves you really knowing your multiplication well, right? Because not everyone's going to immediately look at 48 and say, yes, 16 times 3. I've chosen this pair as opposed to like 24 times 2 or 4 times 12 because it has the largest number possible on this list. I couldn't use 25, 36, or 49 in a multiplication problem to get 48. Once you've rewritten it as this, another way you can think about the square root of 16 times 3, that's the same thing as the square root of 16 times the square root of 3. All I've done is separated out that square root over both of them. The last step would be, well, the square root of 16, we know that's 4. Square root of 3, there is no square root of 3, so it just says square root of 3. Notice Same answer as before. That's what the factor tree is doing, is it's finding that number in 48 that you can square root, and it's leaving inside the square root the number you can't square root. Like I said, different students prefer different ways. This definitely looks shorter, right? Because we didn't have to make that big factor tree, but it can be harder depending on where your multiplication skills are at right now, or just depending on the number. A different example using this method, I'll leave our list here, is something like the square root of 75. If I gave you the square root of 75, we know two different ways at this point to simplify this square root. If you're feeling good about this or okay about this and you want to pause the video and try, go for it. Did you pause the video? Looking at this, so like I said, there's two ways you can do it. If I'm showing you how to do it with this method, again, you're trying to find the biggest number on this list that you can use to write a multiplication problem where the answer equals 75. 75, I think, is a little easier because there's only one option on this list, and that's going to be using the number 25. We can't use anything bigger after 64, and the next square root is 81, which is already too big. So 25 is the biggest number on this list we could use. I would rewrite it as the square root of 25 times 3. And then you can do this, you don't have to if you don't want to write it like this, but you can separate it out like that. And then we could say the square root of 25, well, that's 5. Square root of 3, there is no square root of 3. I mean, there is, but it's a decimal. So we'll keep it as square root of 3. And there's your answer. So quick. Only so quick, though, if you know your multiplication. If you aren't as confident in this method, you could get the exact same answer by doing a factor tree. If I use 75 for my factor tree, we did this earlier. So if you, I'm sorry guys. So if you did your factor tree earlier, we saw that it ends up being 25 and 3, 5 and 5. And then we ended up saying there's a pair of 5s that go outside. There's a 3 that goes inside the square root. I'm not going to refilm this. But it's just showing you, right? You can use the different methods and get the same answer. Let me give us a real different question now. Sorry, guys. The next one, okay, that is actually a new question, is the square root of 300. I am going to ask you at this point to pause the video, try this on your own, choose whichever method you want to try. Some students like to try both. It's up to you though. But go ahead, pause it, and then come back to see if you got the right answer. And you're back. I think this is a good example of when this is going to be an easier method to use. If you did a factor tree for this problem, you probably got a really big factor tree, right? Because 300 is very large. If you're using this method of finding a number inside that you can square root, 300 is one of, I think, the easier ones. Just because a lot of us are familiar with square root of 100, right? So I could see 300 and say, well, that's the same thing as the square root of 100 times 3. Square root of 100 we know is 10. Square root of 3. All my problems have square root of 3 in it. That's not always the case. But then we get 10 square root of 3. If you're doing a factor tree, there are many different factor trees for this problem because the number's so big. But you would end up having a pair of 2s and a pair of 5s that went outside your square root. And then the 1 3 by itself inside the square root, which would give you 10 square root of 3 as well. There's one last type of problem you could see with simplifying square roots. It's really similar to what we've been doing, but it looks a little different, so it can confuse students. It's what to do with something like this. If they're asking you to simplify a square root, but you're starting off with a number in front of the square root. Simplifying the square root is going to be the exact same method you've been using for all the previous problems. If you're doing a factor tree, it would involve looking at the number inside the square root and making a factor tree for that number. If you're using this method, same idea, looking at square root of 18 and finding one of these. I'll do factor tree again If we have 18, we could use 6 times 3. 6 would be 2 times 3. So when we go to simplify the square root of 18, we've got a pair of 3's. So I would put 3 outside, and then we have a 2 by itself. So 2 would go inside. The only difference with this problem is we're starting with a 5 outside the square root. So when you go to place all your numbers, you want to place the 5 outside the square root as well. So really, it's like simplifying the square root of 18, and you're just bringing down this 5 into your answer. So that our final answer would be, well, 5 times 3 is 15, and we get 15 square root of 2. So I think one last question I'll give you to try, one like this. If you want to go ahead and try, let's do 5 square root of 98. Again, use whichever method you want, factor tree, finding a square root inside 98. But go ahead, pause the video now so you can try. And you're back. I'm going to use this method for this one. I know 98 is the same thing as 49 times 2. I've chosen that one because we can square root 49. We could say the square root of 49 is 7. We cannot square root 2 though, so that would stay inside the square root. We end up getting 5 times 7, which is 35. So our final answer would be 35 square root of 2. I hope you're feeling better about this lesson. I hope you're having a wonderful day as well, and I will see you all soon. Thanks. Bye.